chemistry teacher. Today I have made a video for the students of class 10th under the chapter chemical reaction and equation. In the last video, I have given you a homework regarding the calculation of oxidation state of elements underlined in the given compounds. I hope all of you have done the homework. Today, I would like to provide you the answer of the question given you as your homework so that you can check your answer. The first compound was given to you. Remember, it was HCl, in which you have to calculate the oxidation state of chlorine. You know, HCl is a compound and the total algebraic sum of the elements in a compound, the total sum of oxidation state of all elements in a compound is 0. So HCl is equal to 0. And the oxidation state of hydrogen is +1. Consider the oxidation state. Let the oxidation state of chlorine is X. So X is equal to -1. The second compound which was given to you to calculate the oxidation state of nitrogen was N3H, in which you have given nitrogen to find its oxidation state. Again, it is a compound. The sum of the oxidation state of all elements in a compound is 0. Now, we calculate the oxidation state per atom of the elements. Here there are 3 nitrogen atoms. Therefore, we shall use 3x. And for hydrogen, the oxidation state is 1. Therefore, 3x is equal to -1, x is equal to -1/3. The third compound was KAgCN2, in which you need to calculate the oxidation state of silver. Again, this compound as a whole we shall write 0. Potassium is an alkali metal whose oxidation state is +1. Use X for silver. And Cn is an ion, cyanide ion. In the last rule, I have provided some common molecules and ions with their charge, and I have told you to learn the charges of the ions given in the 10th rule so that you will feel convenience in solving such kind of questions given in your examination. So cyanide has charge -1, and here there are 2 ions, therefore we shall multiply it with 2. So +1 plus x -2 is equal to 0, therefore x is equal to +1. The next compound was H2SO5. This is very important compound. And it is the exceptional compound. It is an acid called peroxymonosulfuric acid. And this compound was made by a chemist called Caro. Therefore, this compound is also known as Caros acid. And to calculate the oxidation state of sulfur in this compound, you need to know the oxygen atoms which are linked by peroxide bond. And for that, I would like to make you understand the structure of this compound. The structure is hydrogen, single bond oxygen, and single bond sulfonic group. SO3H is called sulfonic group. Since this acid has one sulfonic group, therefore it's and one peroxide bond, therefore its name is given peroxymonosulfuric acid. Now you can use the oxidation state of hydrogen +1, oxygen here -1. You know, in peroxide the oxidation state of oxygen is -1. And let the oxidation state of sulfur X for oxygen -2 into 3 and for hydrogen +1, and total sum is equal to 0. Therefore we shall write +1 -1 plus X -6 +1 is equal to 0. So X is equal to +6. Right. If you will calculate the oxidation state of sulfur without knowing its structure, the oxidation state of sulfur, what will be the oxidation state of sulfur? Here I would like to make you understand, to check your mistake. H2SO5, like all general compounds, if we shall calculate the oxidation state of sulfur, we shall use +2 for 2 hydrogen atom, plus X for sulfur, and -10 for 5 oxygen is equal to 0. X is equal to how much? +10 -2 is equal to +8. And I have taught you one rule. The maximum oxidation state of an element is equal to its group number. And if you will decide the group number of sulfur in periodic table, or if you will see the place of sulfur in periodic table, you will find it belongs to group 6A, just below the oxygen. Right? Sulfur belongs to group 6A or group 16. Here we have to take the Mendeleev's group, the group determined by, decided by Mendeleev, that is 6A. The group number of sulfur is 6 and the oxidation state we have calculated is 8, which indicate the oxidation state of sulfur we have calculated is wrong. It means there is some mistake. What is that mistake? That we can correct by knowing the structure of this compound. Peroxy monosulfuric acid, it has one peroxide bond and one sulfonic group. Clear? Now the next compound which was given to you is H2S2O8. H2S2O8. Fifth, in which we have to find the oxidation state of sulfur. Again, it is also an exceptional compound. It is very important. It is usually asked in the examination. Even in the competitive examination, this compound is asked to calculate the oxidation state. Again, we use its name. Its name is peroxy disulfuric acid. Peroxy disulfuric acid, and this acid was made by a chemist called Marshall. Therefore, it is also called Marshall's acid. Right? Now you used to write the structure of this compound: SO3H, single bond O, single bond O, SO3H. Means two sulfonic group. Here, two sulfonic group is linked with a peroxide, linked with the oxygen atoms, which are linked with by a peroxide bond. So this is peroxide bond. One peroxide bond is there. So we shall use X for this sulfur, -2 into 3 for this 3 oxygen, +1 for hydrogen, and -1 for this 2 oxygen, which are linked by peroxide bond. This is peroxide bond. Plus X -2 into 3 plus 1 is equal to 0. Now, X -6 plus 1 minus 1 plus 1 minus 1 cancelled. X 2x -6 minus 6 minus 12 is equal to 0. 2x is equal to plus 12, x is equal to plus 6. Again, you can check the general calculation of oxidation state of sulfur in this compound. H2S2O8 is wrong, is equal to 0, plus 2 plus 2x minus 16 is equal to 0, 2x is equal to 14, x is equal to 7, which is greater than group number of, plus 7 is greater than group number of sulfur, which is 6A. Right? Now the next compound is NiCO4. This is called nickel carbonyl Again, here CO is a molecule and its oxidation state we shall use 0, which is given in the 10th rule. Nickel X plus CO0 is equal to 0, X is equal to 0. Here the oxidation state of nickel is 0. Now next question is S4062 minus. It is a ion. It is an ion. Therefore, the total sum of oxidation state of elements in an ion is equal to the charge present on the ion. Here charge present is -2. We shall use 4x minus 12 is equal to -2. 4x is equal to 10. X is equal to 10 upon 4, that is 2.5. The next compound is, next question is again an ion. PO43 minus is equal to -3, P is equal to X, -8 is equal to -3, X is equal to +5. Next is also an ion, PO33 minus is equal to -3, P is equal to X, -6 is equal to -3, X is equal to +3. Now the next question is NH4 plus. It is also an ion. So we shall use +1. Nitrogen. We have to calculate the oxidation state of nitrogen. Let it is X. 4 for hydrogen +1. X is equal to -3. Next ion is given NO2, nitrite ion, minus is equal to 0, N is equal to X, minus 2 into 2, 4 is equal to 0, is equal to -1, is equal to -1, is equal to -1 plus 4 is equal to +3. Next one is 12. Again, it is very important compound because we have to calculate the oxidation state of both of the nitrogen atom present in this compound and the oxidation state possessed by these two nitrogen atoms in this compound are different. How can we calculate? We calculate it into two parts. In first part we calculate the oxidation state of this nitrogen, and in the second part we shall calculate the oxidation state of the next nitrogen atom. Is equal to 0 because it is compound. NH4 and O3 is equal to 0. Here we shall calculate the oxidation state of this nitrogen atom. And we shall use this NO3 as a whole, an ion whose charge is -1. That we shall remember from the 10th rule. In the 10th rule, I have provided NO3 having charge -1 called nitrate ion. The nitrogen X, hydrogen +1 into 4 plus 4, and NO3 as a whole. charge minus 1 is equal to 0, to x is equal to plus 1 minus 4 is equal to minus 3. And in the second part calculation, we shall calculate the oxidation state of this nitrogen atom. Again, we shall use as a whole charge of this compound is 0, and here we shall consider this NH4 plus as a whole ion. Here in the 10th question we have practiced NH4 as a whole contains plus 1 charge. So we shall use plus 1 for NH4 plus ammonium ion, X for this nitrogen, and minus 6 for 3 oxygen atoms. X is equal to here plus 5. Now the next compound is also very important because it belongs to the exception of the oxidation state of oxygen. CrO5. CrO5, in which we have to calculate the oxidation state of chromium. This is chromium peroxide. Chromium peroxide, you need to keep the structure of chromium peroxide because it is an exceptional compound in which 4 oxygen atoms are linked with 4 oxygen atoms belongs to a pair of peroxide bond. Both this one and this one are peroxide bond. We can mention it like this. Peroxide bond. As a whole, the total sum of the oxidation state of all elements in this compound is equal to 0. Consider the oxidation state of chromium is X. We shall use minus 1 for this oxygen. Minus 1, minus 1, minus 1. But minus 2 for this oxygen atom because it is a general oxygen atoms linked with double bond with chromium, which is not a oxygen atom of peroxide bond. The total we shall calculate minus 1, minus 1, minus 1, minus 1, minus 2 means minus 6 is equal to 0, therefore x is equal to plus 6. And the last compound which was given to you in your homework list was H2CO3, carbonic acid. In this we have to calculate the oxidation state of carbon. This we can calculate simply like the general compounds. Hydrogen, 2 atoms of hydrogen are there. So we shall write plus 1 into 2 for hydrogen, X for carbon, minus 2 into 3 for oxygen is equal to 0. Plus 2 plus X minus 6 is equal to 0. So X is equal to plus 4. Dear friends, I have provided clear concept of the calculation of all the compounds given in your question as your homework. Please check your answer tally with the answer provided by me, and if you feel any difficulty, any confusion, if you have, you ask your confusion, your queries, your questions, your difficulties either through your comments or on call as per your wishes, as per your requirement. In the next video, for the student of class 10th, I shall continue under the heading redox reaction, and in the next video I shall discuss another very important questions which are used to ask in several kinds of the internal examinations, board examinations, as well as in the competitive examinations. And that question is, how do we know the substance oxidized and reduced in a given chemical reaction? Also we shall be able to know after watching the next video provided by me whether the reaction given is a redox reaction or not.